Hi, this video covers section 10.2 in which we talk about yet another way of solving quadratic equations. And this is something you should have seen before. It's the quadratic formula, which should be familiar. Again, it's good for when we have quadratic equations in this form where everything's set equal to 0. To use a quadratic formula, you have to have everything equal to 0. And it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so, again, this should be something you've seen before, but let's go ahead and take a look at how we'd use that for a couple of examples. What do we have to do first in this example A? Well, it's not set equal to 0, so the very first thing is we should probably make it look like x squared minus 6x plus 7 equals 0, and then we can tell what a, b, and c are. A is the number or coefficient in front of the x squared, and it's not written there, but we know there is an invisible 1 there. And then b is the number in front of x, which is negative 6. And of course c is the number that's by itself, that's the positive 7. And so what we do is we just go and take these three numbers and we plug them into our formula. X equals negative b. X equals negative b, or the opposite of b, and if b is a negative 6, that means that we're going to write the opposite of that, a positive 6, plus or minus the square root of b, which is negative 6 squared, minus 4 times a. A is 1 times c. C is 7, and this whole thing is divided by 2 times a, and a is 1. And so then we go about simplifying. You can see why we talked about in chapter 9 about simplifying square roots, because here we have the square root as part of this formula. So we have 6 plus or minus square root of 36 minus 28. 4 times 7 is 28 over 2. Now we can keep going here. This is equal to 6 plus or minus the square root of 8 over 2, which is equal to 6 plus or minus 2 square root 2 over 2, because 8 is 4 times 2. And then when we go to simplify, sometimes this is where students get mixed up, and so probably the easiest way to think about this, though, is to split this apart into two parts, to rewrite it as 6 over 2 plus or minus 2 root 2 over 2. This is the way you're going to see me simplify it. And then this simplifies because 6 goes into, or 2 goes into 6 3 times. And then here 2 goes into 2 once. And so this simplifies down into 3 plus or minus just the square root of 2, which again is two answers. And sometimes it might be worthwhile to leave it like this. A lot of times my math lab is going to want you to leave it in exact form. This is exact answer. You should be familiar with leaving as an exact answer, but we can also find an approximate answer. And so that would be what happens when we get 3 plus the square root of 2 and 3 minus the square root of 2. You're going to want to pull out your calculator again. You calculate 3 plus square root of 2 and 3 minus the square root of 2, which approximates to about 4.4 and 1.6. About 4.4 and 1.6. Approximate answers are especially important when we're talking about application problems, which we'll see on the next page. So that's the first one. Let's go ahead and take a look at another one of these. Again, we need to get the quadratic equation set equal to 0. So we need to make this 2x squared, and when we move the positive 3x over, it becomes a minus 3x. And when we move the negative 3 over, it becomes a positive 3. Again, we can list what a, b, and c are equal to. You should be able to do this. Go ahead and take a sec and write those down. A is equal to 2, b is equal to negative 3, and c is equal to positive 3. And so when we go ahead and plug it in the quadratic formula, we get x equals the opposite of b, which since b is negative 3, this is a positive 3, plus or minus the square root of b squared, so that's negative 3 squared, minus 4 times a is 2, times c, which is 3, and that's all over 2 times a, so 2 times 2. Same way we did the last example. So this one can then simplify to 3 plus or minus the square root of 9 minus 4 times 2 is 8. 8 times 3 is 24. Over 2 times 2, which is 4. And simplifying further, we have 3 plus or minus the square root of negative 15 over 4. And this presents something that we've talked about as well, because when we have the square root of a negative, we know we can pull an I out. So this is 3 plus or minus I times the square root of 15 all over 4. And this is 2 complex solutions, like we talked about in chapter 9. So sometimes we can get answers like this. We could also rewrite this as 3 over 4 plus or minus root 15 over 4i. Let's say x is equal to that. Or we could say it like this. Either one of those would be acceptable answers in my book. So that's how we use the quadratic formula. And notice we've done this twice. We got 2 real answers in example A, and we got 2 complex answers in example B. And something just kind of interesting to look at, I never will test you on something like this, but when we have the quadratic formula, the discriminant is a name we give to the radicand part of the quadratic formula. It's the part that's under the square root, the b squared minus 4ac. Well, something different happens with the quadratic formula if that radicand, the discriminant, is equal to 0, greater than 0, or less than 0. If it's equal to 0, then that means that this becomes negative b plus or minus the square root of 0, which is just 0. So it just becomes negative b over 2a, which means the plus or minus part is non-effect. It just becomes negative b plus or minus 0 over 2a. It means this part we don't even have to worry about. There's just one real solution. Now when the discriminant is positive, that means we're taking the square root of a positive, which gives us answers. It gives us real numbers. So in this case we get 2 real solutions. That was like example A above. And then there's also the case where that radicand, the discriminant part, is less than 0, and that's where we get the two complex solutions that have imaginary part to them. And so let's see how this plays out, the discriminant plays out, and how it's helpful. If we take a look at this first one, the discriminant, b squared minus 4ac, is equal to 11 squared minus 4 times 10 times a negative 6, which is 121, plus 240, which is 361, which is greater than 0. And so that's that first case, or the second case. That's when it's greater than 0. And that means we have two real solutions. The second one here is actually the problem we already did. That was the example B above up here. The 2x squared equals 3x minus 3, and we already found the discriminant here. We found it to be negative 15. So this one, the discriminant, b squared minus 4ac, rather than doing that work again, we know it's negative 15, which is why we got two complex solutions here. And then the last one, the b squared minus 4ac, is equal to negative 12 squared minus 4 times 9, which is 144 minus 144, which equals 0. Which means that this will have one real solution. Again, I don't test you on things like this. It's just something that's kind of interesting to look at, to really understand what's going on with a quadratic formula. Now let's go ahead and look at an applied problem here. One of the main applications of quadratic equations is projectile motion. When something is thrown up into the air and gravity takes hold and it comes back down to earth, that path, whether it's the path of a football or a missile or a firework or anything that flies up in the air, it comes back down, it follows a path that looks like a parabola, which we're going to talk about a little bit later. A parabola is the shape of a quadratic. And so when I have a function that looks like this, h of t equals negative 16t squared plus v0 times t plus s, this is a function which represents the projectile motion or the flight of an object through the air. And it changes depending on what the v0 is. v0 is the initial velocity. It's what the velocity of the object was right when it was launched. And then also knowing s, which is the initial height of the object. And so in this example, it says a projectile is launched upward from a platform that is 60 feet above the ground, and the initial velocity of the projectile is 100 feet per second. We're given right there what v0 and s is. It tells us it's launched from a platform that's 60 feet above the ground. That means s, the initial height, is 60 feet. It also says with an initial velocity of the projectile at 100 feet per second. So v0, that's the initial velocity, is 100 feet per second. So I could write, it asks to find the function. I just plug those into our function, our h of t function. H of t is equal to, what does it say? It says negative 16t squared. Our highlighted function up here is negative 16t squared plus v0 times t, but v0 in this case is 100, so plus 100 times t, and then plus s, and s is 60. Pretty easy. There is our function that we're going to use for this example. Now it says, how long will it take for the projectile to land on the ground? Well, let's think about this. If the projectile is launched from a building that's 60 feet up in the air, it's launched from that building, and it flies up, it reaches its maximum height, and it comes back down, and it hits the ground. When it hits the ground right here, at that point the height is equal to what? Well, it's on the ground. It's not above the ground, it's on the ground, so the height is 0 feet. It's nothing. Well, if I look at this function up here, where's the height? The height is a function of time, so this left-hand side is the height that we're talking about. So that means, what are we going to set equal to 0? We're going to set h of t equal to 0. We're going to have 0 be equal to negative 16t squared plus 100t plus 60. And we know how to solve stuff like this. We can use the quadratic formula. We can try to factor. The very first thing I would say is that typically we don't want that squared term to be negative, so let's go ahead and move everything to the other side. That makes it a positive 16 squared, a negative 100t, and a negative 60. And then we could talk about factoring out a GCF, something that's common to all four of those terms. Just to make this quadratic a bit simpler, I would suggest that we pull a 4 out of this thing. If we pull 4 out, that makes this 4t squared minus 25t minus 15. And that could be factorable, but it's probably not one that you'd want to factor because it's a little bit ugly. This might be a good place to use the quadratic formula. So we could say that, and it's not going to be x equals in this case because we're solving for our independent variable of t. It's going to be t equals negative b, which is a positive 25 since b is negative 25, plus or minus the square root of b squared minus 4 times a times c. So this gives us a equals 4, b equals negative 25, c equals negative 15. And this is all over 2 times 4. So this is 25 plus or minus the square root. 25 squared is 625. And we have a negative times a positive times a negative is going to be a positive. 4 times 15 is 60, and 60 times 4 is 240. All over 8. So this is 25 plus or minus the square root of 865 over 8, which is 25 plus or minus square root of 865, which is about 29.4. So this is about 29.4 divided by 8. Now you can see, again, remember this is two answers. It's 25 plus 29.4 divided by 8, and it's 25 minus 29.4 divided by 8. One of these we don't want to use. Which one don't we want to use? Well, obviously the bottom one is going to be negative because 25 minus 29.4. This is a negative answer, and we don't care about negative times. We really only care about this positive time on the first one. So if I pull my calculator back out, I'm not going to round yet. I'm going to take this 29.4. I'm going to add it to the 25, which is about 54.4, and I want to take that answer and divide it by 8. And this gives us a time of about 6.8 seconds. It's the time it takes for the ball to hit the ground. Likewise, we could go ahead and find in part C when the projectile will be 125 feet off the ground. Well, instead of h of t being at 0 feet, we now want to figure out when h of t will be 125 feet. So this is basically the same thing, but now we're going to say 125 is equal to negative 16 t squared plus 100t plus 60. And again, we want to get everything on one side. So I would subtract 16t squared. I would add 16t squared. I would subtract 100t, and I would subtract 60 from both sides. And so this would end up giving us the equation (16t squared minus 100t plus 65 equals 0. And we could solve this with a quadratic formula. I'm not going to take the time on this video to do that. We know how to do it. You end up getting two answers here. You end up getting that t is equal to about 0.7 seconds, and t is equal to about 5.5 seconds. So I'm going to leave you to go ahead and try to come up with those answers, but basically the reason why there's two answers, and we're going to keep both of them because they're both positive answers, is that when it gets up to 125 feet, it's going to hit that in two places. It's going to hit it on the way up. Say if this right here is at 125, and I know this isn't to scale, but if this is 125 feet, it's going to hit it on the way up, and it's going to hit it on the way down. It's going to hit it in two spots. So that's the reason for the 2 seconds. Right, go ahead and don't forget to finish up your self-check, and I'll see you in class. Thank you.